Hey everybody, this is Peter from peterstestprep.com, and today we're going to learn about averages and medians. This is the first of a two-part set of videos. The first part one, which is what we're going to do today, is looking at the less difficult material. This is the material that everybody should want to know. You really want to know everything that's in here, and you're going to want to follow along with the worksheet that you can print out. Now the worksheet, you can download it from the link that sits below the video in the description of the video. Download it, print it, follow along. And as we go along, I'm going to stop every now and then and say pause the video, at which point you should do so, and do the questions that I'm going to tell you to do. In other words, what we do is you teach you a lesson, and then you practice it with a couple of questions, then we go over it, and then learn some more material after that and follow that cycle. So when you're ready, let's begin.
I've got up on the screen here page 1 of the Averages, Medians, and Mode Part 1 worksheet. And I'm going to zoom in and let's start where we should begin on the left side. So the averages, which they also use the word mean, we always use a simple formula for this. Everybody knows the formula for finding the average of a group of numbers. The average is always equal to the sum of the numbers divided by the number of terms. Now, that's the easy part. The question is, what do you do with these medium level word problems that begin like this? So many medium level word problems begin this way. It says here, the average of a group of 4 scores is 21. How should you respond to this? The way you should respond to this is by setting up an equation to find the sum of the numbers. So this right off the bat is the key to handling a lot of word problems dealing with the average. The average is equal to the sum divided by the number of terms. And usually they will tell us the average, which I put over here 21. And I know there's 4 scores. That's the number of terms. So we put that in the bottom. And the unknown is x. And that's what we want to solve for. I'll do this one time here, but you guys should know how to do this. I'm going to solve for x. Easiest way is just put this over 1 like so, cross multiply, and I get x equals 84. And that's the key. So there are 2 keys to doing these types of problems. 1, find the sum of the original group of numbers first, then move on to the next step in the problem. Number 2, don't worry about not knowing the individual numbers. You usually don't need to know the values of the individual numbers in the list. The key is the sum. When you know the sum, when you calculate that x, you've got to stop and think about what you just did. You know the sum of the original group of numbers. Let's apply this to a problem. Let's go to the bottom of the left-hand column here and do 1a together. The average of a list of 5 numbers is 39. And I stop there. Automatically, I want to get the sum of those 5 numbers. So I set up 39, which is the average, is equal to x over 5. The unknown sum is x. The number of terms is 5. That's my first step. And I solve that for x, and my sum, the sum of the 5 numbers is 195. I don't know any of the individual numbers. I don't care. I don't need to. Now we can go to the next part of the problem. A 6th number with a value 57 is added to the list. What will the new average be? Well, if I understand that the sum of the first 5 numbers is 195, I know that all I need to do is add the 57 to the 195. That gives me my new sum. And I'm going to divide that by the new number of terms, which is 6, and I'll get our new average, which I believe is 42. Once you know how to do the problems and get them started, you always have a good chance to be able to finish it. There's 3 problems on the right-hand side. This is so important that I'm going to have you do these 3 problems, 1B, 1C, 1D. I almost said stop the videotape, stop the video, shows you how old I am, and you'll always see a little blue screen pop up for 3 seconds that tells you what problems to work on, and pause the video, and then when you're done and you've done your best to answer them, come on back and we'll review them. Let's look at 1B. The average of 6 scores is 90. I stop there. That's the first step. Let's get the sum of the 6 scores. So the average of 90 is equal to the unknown sum divided by the number of terms 6, and I get x equals 540. That is my sum of the original 6 numbers. Then they tell us that the sum of the scores change. But notice, we don't know what the scores are individually, and we don't need to know. We just need to know how the sum is effective. If one of the scores is changed by raising it 24 points and another is changed by lowering it 6 points, what will the new average be? So for the next step, we take our sum of the original 6 scores. The sum was increased by 24 because one of the scores was increased by 24, and then 6 points were taken away from another score, so our sum decreases by 6, and that new total will be my new sum, and I'm going to divide that by the same number of terms 6, and we get 558 over 6, and we get 93 as our new sum, as our new average. 1C, the average of 3 numbers, is 9. Stop there. 9 equals x over 3. X equals 27. That is the sum of our original 3 numbers. Now there's a couple of ways to go about doing the next step here. They tell us that there's a 4th number added to the list, an unknown, and the new average is 11. Well, I know that I have a new average of 11 and I have 4 terms. So I can calculate my new sum for the 4 terms, and that's 44. If the sum of the first 3 numbers is 27 and the sum of the 4 numbers altogether was 44, the difference between them, 44 minus 27, 17, has to be the difference. I'm going to quickly give you an alternate step 2 here. My new average is 11, and I can find the difference by taking the original sum, 27, and I'm adding this unknown number x to it. So we're looking for the new number x here, and divide that by 4, and when we solve that, we'll just jump right to x equals 17. So if you didn't do it that way and you did it this way, that's fine. Don't even pay attention to what I said. Let's go to 1D. Classic situation now. There's 2 different equations that we're going to set up here. The first goes for store A. For store A, the average volume is 20, and there's 10 terms, or 10 radios. So the sum is 200. For store B, we have an average decibel rating of 40, but there's only 5 radios, and my sum in this case is also 200. To find the total average, we need to find the total sum and divide it by the total number of items. I have a total decibel rating of 200 plus 200. That's my sum of all my decibels. The total number of radios is 10 plus 5. So 400 over 15, and that gives us an average of 26.6, or 26 2/3. Let's go on to the second page now and look at our second topic, which is the topic of averages and frequency tables. Let's look at this problem here. We have a parking lot with 15 cars. Edna compiled a list of the gas mileages of all of the cars. Her results are summarized in the frequency table below. Find the average gas mileage of the cars shown in the table. So just to quickly summarize where we're at here, there's 15 cars. So her original list has 15 numbers in it. But because some of the cars have the same gas mileage, what Edna does is to condense the list. So this is our frequency table. There's 2 cars with a gas mileage of 13. 6 cars with a gas mileage of 25. How do we find the average here? Really easy. The key is must find the true sum. We cannot just simply add 13 plus 20 plus 22. We've got to find the true sum, which is the sum of all 15 cars. And you do that by multiplying the frequency times the corresponding number. So 2 times 13 is 26. The 2 cars that have a gas mileage of 13 each contribute a 13 to the list. So 13 twice is 26. And I'm just going to quickly run through and fill in all the remaining numbers here. 150, 120. And our true sum is 360. There's 15 cars, so to find my average, I divide the true sum by the number of objects. 360 divided by 15 is 24. That is our average miles per hour. Let's have you try 2B and 2C. Go ahead and stop the video and do 2B and 2C. See you soon. To find the average number of languages spoken, we first have to find the true sum because we have a frequency table. We have multiple students that speak each number of languages. So 4 times 6 is 24, and I'm just going to multiply across. Let's just write down all of these numbers. I'm just going to quickly go through this for you to get to the result. The true sum is 51, and we have, how many students are there? 17, so we do 51 over 17. 3 languages spoken per student is the average. In 2C, we have a class. There's a total of 16 kids here. And the frequency table, well, it's written in the form of a bar graph, but the process is the same. 10 students scored a 75, so I have to multiply the frequency times the score. 4 students got an 80, 2 students got an 85. We've got to multiply those pairs, add it all up, and I get 1,240 total. And I'm going to divide that by the 16 kids, and we get an average score of 77.5. The next topic is medians. Some basic things about medians. The median is the middle number of a list of numbers written in ascending or descending order. Taking a look at 3A, find the median of this list of numbers. Your first instinct might be to go // 45, but there's a problem. That's not right. The numbers are not in order. They will try to trick you in that way, and I see students get tricked by that when they're not thinking. We've got to reorder the numbers, put them in ascending order. Now when we cross out from the ends, we get 23. So as it says in the box, the numbers in the problem may not be in order. Number 3B, find the median of this list of numbers. Cross, 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 cross. Now we're left with 2 numbers in the middle. As you probably know, then when you have an even number of terms, take the average of the 2 middle numbers, and that gives you the median. Let's go on to page 3, and you'll see that there are 3 problems dealing with medians on the left-hand side here. So let's have you take a look at the 3 problems, 3C, 3D, 3E. Pause the video and take a look. Starting with 3C, we have an even number of terms. There's 8 terms. So when you slash your way to the middle here, crossing out 1 on each end, we're left with 2 numbers in the middle. And since the median is 86, we know that the average of x and 88 has to be 86. So this is enough information to tell us what x is. And you can probably just eyeball this and say, oh yeah, it's got to be 84. Or we can set it up. The average of the 2 middle numbers, so I add up x and 88 and divide by 2. I set that equal to 86. That r is an 88. And you can solve that for x, and you'll get x equals 84. In 3D, this is a little bit of a theoretical question. You have a list of 5 numbers. They're written in ascending order. We are told that x is the median. What is the smallest value x can have? Now, some people say 14, but the problem did not limit you to integers. Then some people will say 13.0001. Well, that's pretty small. But how about 13? X could be 13 and still be the median. Or not, put it another way, if x is 13, 13 would be the median. and that could be x. So the median, as it says in the box here, can have the same value as the number next to it on either side. Finally, let's move on to 3E in the bottom of the page. There's these 5 high schools, the questions about the median. We need to write all of these out. Don't keep this information in your head. Make yourself a little schematic, which I will do now. So the E High School, Euripides High School, has 645 students. Theseus's High School has 799. And I'll just continue here. Homer, 820. Odysseus, 1001. And Sophocles, 1112. Now, how many students should be added to Theseus High School in order to make Odysseus High School the median? Well, you need a little bit of insight. You need to recognize that you've got to add enough students to Theseus to get it into that section there between Odysseus and Sophocles. And because no two schools can have the same number of students, we can see then that we need to get this to 1,002. So the answer will be the difference between 1,002 and 799, or 203 students, like so. And so our new list will be E645, T, no, we've got H now at 820, then Odysseus at 1,001, then Theseus at 1,002, and Sophocles at 1112. Section 4 on the top right side here, we're on page 3 still. We want to find the median value in a frequency table. They love asking questions about the median value on a frequency table. Take a look at 4A before we go to the box up above, and let's just consider what we have here. Here's our table that we looked at before of the 15 cars with the different gas mileages arranged in a frequency table. If we're trying to find the median gas mileage, you can't just slash from the ends here and assume that the answer is 22 there in the middle. That's not how it works, because you're not taking into account the fact that there are a different number of cars that have different gas mileages here, and they're grouped in different size groups. What's an easy way to do this? Well, there's a little formula that we can use to make this really, really easy. So if you take a look at the box, it says to find the median value in a frequency table, use this formula. The median count value, and we'll explain what that means, is equal to n plus 1 over 2, in which n represents the number of items. Then you count to that number of items from either end of the list. This is tough to understand, but once we do it, you'll see how easy this is. So there's 15 cars. I'm going to add 1 to that and divide that by 2. So I get 16 over 2 is 8. That is my count value, or my count number. I'm going to count to the 8th car, and I can do that from either end of my list. 1, 2, 3, 4, 5, 6, 7, 8. And the gas mileage of 25 is my median. Or I can start from the other end. 1, 2, 3, 4, 5, 6, 7, 8. And we're in the same place. So the median is 25. So use this little formula when you're looking to find the median. And actually, you can use this for any median question to find the median. You can always just take the sum of the number of items and just add 1 and divide it by 2. And you can just count from either end instead of doing the slashes. We're going to have you now take a look at questions 4B on this page and 4C on the next page. And also 4D, actually. So stop the video and go ahead and do those 3 problems. In 4B, when we add up the total number of students, the seniors, we get 213 of them. In order to find the median number of siblings per student, we apply our little formula. So 213 plus 1 over 2 is 214 over 2, which is 107th, and we're just going to count from to the 107th term from either direction. Since 45 plus 70 is 115, we know that the 107th student will be in here, and so the median number of siblings is equal to 1, and it's that easy. Let's go to 4C. Now, we have a little bit of a different problem here, because now what we're going to find is we have actually an even number of families at 30, and we want to try to figure out what the median number of cars per family is. The problem is that when we take our 30 and we apply the formula, 30 plus 1 divided by 2, which is 31 over 2, we get 15.5. Hopefully you were able to figure out that that means that you're actually going to need to look at the 15th and the 16th terms counting from either direction. And that should make sense to you because when you have an even number of terms, you're going to need the middle two terms, and then you take the average of the middle two. So counting from the top to the 15th term, 1, 2 plus 13 is 15. So the 15th term, the number of cars is 1. But then I go to the 16th term, that takes me to the third row, and the median, I should say the number of cars there for the 16th term is 2. And to find the median when you have an even number of terms is you take the average of the middle two terms, which is 1 and 2, and we get 1.5. We can do the same thing with the bar graph in Mr. Cantaloupe's class. We have the same 16 kids. 16 plus 1 over 2 gives me 8.5, which means we need to find the 8th and the 9th terms. Well, that's going to give you 75 for both, and so the median is 75. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9. 75 for both. Let's go up to section 5 on the top right now. We're on page 4 still. Frequency tables with ranges. That's our new topic here, just building on what we've done before. 5A says, consider the frequency table given below. The graph gives the number of students who scored within specific ranges on a recent national assessment test. So you'll notice now that 8 students scored within a 1 through 10 range. We don't know the individual scores. It's done by range. The approach is still the same. It's still a frequency table. I have here 107 total students. So to find the median range, 107 plus 1 is 108 divided by 2, and we get 54. So counting to the 54th term from either direction, we're going to end up in the 4th row. The median range is 31 to 40. What is the largest possible score then a student could achieve and still be in the median range, or be the median, and that would be 40. So a student could get a 40, and that would be the median score. Finally, we should go to page 5, and we're going to look at another type of graph, cumulative charts. Let's take a look and see what we have here in 6A. The graph below shows the cumulative frequency of scores in a particular class exam, how many students scored in the range of 81 to 90. Look closely at this chart. 10 students scored from 70 to 80. The next bar tells us that 22 students scored from 70 to 90. It does not say 81 to 90, it says 70 to 90. So that means that this second bar includes everybody who was in 70 to 80, as well as the kids who are in the 81 to 90 group, which means that the total number of students who scored 81 to 90 must be the difference between this graph, or this bar, and this bar. So 22 minus 10 gives us 12. And that's how that works. Let's have you try 6B immediately below. So go ahead and stop the video. We have a table here that represents the cumulative amount of money in the cash box at the end of every hour. So at 8 a.m., she had $0. At 9 a.m., there was $10. And then at 10 a.m., she had $22 total in there. This is a cumulative amount of money, right? During which time period did Jane collect the most money? Well, from 11 to 12, she collected $14, 40 minus 26, because the difference between how much she had at 11 and how much she had at noon is 40 minus 26, or $14. Right? So the time period was from 11 to 12. The difference between each row tells you the marginal extra amount that she collected each hour and added to the total from the previous hour. And finally, the last question here, how much money did Jane collect in the hour in which she collected the least amount of money? The smallest difference is between 10 a.m. and 11 a.m. when it went from $22 to $26. During that entire hour, poor Jane only collected $4, and that was from 10 a.m. to 11 a.m. Finally, let's take a look at section 7. Range and mode, our very, very last little section here. Two definitions, very easy, very important. The range of a set of numbers is equal to the difference between the largest and smallest value. The mode is the value which appears the most frequently. So let's take a look at 7a. Actually, I'll have you go ahead and read it and try it and stop the video. And we'll see in a moment. The mean or average of these numbers, I get 7.6 and change. The median, I get 7.5 because the middle two numbers are 6 and 9, so the median is the average of the middle two numbers. The mode is 9 because 9 appears twice. The range is the difference between the smallest and the largest. 13 minus 3 is 10, so the range has the largest value. If you're looking to get your maximum possible score on the math section, you've got to have everything that we just did memorized down cold. Keep it, keep the little packet, 3-hole punch it, store it in a binder, and study these worksheets before you take your next ACT, or study them before you practice on mock ACT exams. Thanks so much for watching. We'll see you in the next video. There's going to be an averages and medians video part 2, much more advanced topics. And so if you're shooting to get into the high 20s or so or more, then you definitely want to watch that video as well. Thanks again.